Hey all, super excited to tell you about DataPoint. To show you the basics, we're going to start with a simple Hello World example. We will be passing an object as an input and do some simple transformation to it. After that, I will show you how to move this transformation to an entity that will allow us to create reusable blocks. So let's start by requiring DataPoint module. To keep things clean, I'm going to reset our console logs on every run. We're going to create a DataPoint instance through DataPoint.createFactory method. Let's create our input object. To do a transformation, we will call the DataPoint.transformation method. This method receives at least two parameters and returns a promise. The first parameter is a transform expression, and the second parameter is the input value. Transform expressions are made up of reducers. Each reducer passes the value from one to the next one asynchronously. The most basic reducer is a reducer path, which starts with a $sign and is followed by an object path. $dot means we're requesting to access the root node of the value. Since the transform method returns a promise, let's add our then method. Here we will receive an accumulator object. Accumulator.value is the result from our transformation, so let's console log this value using json.stringify. By hitting save, you can see the result on the right, which is the entire input object. Let's play with the reducer path. By accessing each level of the object, we can see on the right how the result changes as we access deeper into the nodes. Now let's do some actual transformation. We will create a reducer function. Reducer functions are asynchronous functions that accept two parameters. The first is the accumulator object, and the second is the next function. This function is a node style callback. This allows us to create any asynchronous operation within the reducer. The next function accepts two parameters, error first and new value second. Because there is no error, let's pass null as first argument and accumulator.value as the new result. This, of course, should produce no effect. To use multiple reducers, we must create our transform expression into an array. Remember, the reducers get executed serially and asynchronously. We already have our reducer path. Now we will add our new reducer function to the mix. To make sure our function is getting called, let's change the reducer function to a hard-coded value. We can see the value reflected on the right. Now that we know how this works, let's change the second argument to accumulator.value and call the toUpperCase method. The console is reflecting our changes. Now let's add a new reducer. This reducer will split a string in words. Same as with our first reducer, we must add the new one to the chain of reducers in our transform expression. Now, let's use DataPoint's main feature, entities. Entities allow us to reuse transformations. To add entities, we can use the addEntities method. This method receives an object. Each entry in the object is assumed to be a valid entity. Entity keys follow a specific format. First is the entity type, followed by a colon, and then the entity ID. For now, the value of this entity will be a root reducer path. Next, let's remove the reducer functions and place our new entity instead. The console is back to our initial hello world. Let's go back to our entity and let's change it so it calls the toUpperCase reducer. Okay, now let's add the split reducer. We see the change reflected in our console. So what if we have multiple messages? To map each item from the result of one reducer to the next, we can add closing brackets at the end of an entity ID. This will map each message to our transform entity. So now on our console, we can see the result of the mapping we made. That's it for our Hello World example. We only scratched the surface. I hope this gets you interested in learning more of DataPoint. Thanks.